Okay, so now that we've seen the Rube Goldberg machine, let's go into the different pieces of it. So the first piece we saw involved eddy current braking. Basically what that meant was when you drop a magnet through a copper pipe, it falls slower than it would have under normal gravity. So if we look into the equations for this, this is what we see with eddy current braking. So basically it's the electromotive force is generated by the changing magnetic flux through the pipe. So the pipe, since it's copper, it's not a ferromagnetic, so it's not a magnetic force, but once the magnet goes in, it induces a eddy current around the pipe. That's showing it rotating. And as that current is induced, we have a responsive magnetic force opposing it, the negative sign that came in the equation. So the pipe ultimately slows down the magnet. So the second piece of this was with the EMF, continuing on with Faraday's law, and it was inducing voltage via having a magnet come through a coil. So if you see here, we've got our multimeter, and when you drop the magnet in, you can see it jumps up to 1 millivolt. So it's not very much we're getting out of here. That's likely due to the fact that the magnet itself isn't that strong. But you can see that just the relative motion of the magnet is causing some voltage inside the wire. Okay, so the third part was the dominoes were connected to this homopolar motor field, and basically we had strings attached to the dominoes that would have a paper to stop the copper wire from touching the magnet. So the copper wire acted as the brushing, so once the current made contact, basically once the copper wire made contact, we had a current path, and then once you have the current path, that's when you have the interaction with the magnetic field, creating a force in the clockwise or counterclockwise direction, depending on where the positive and the negatives were. So we had a few of these going. You can see if we were to switch it upside down, they were just rotating in reverse just due to which way the current path was. Okay, so the next thing we had was the electric train, which we had partially reviewed in class. But basically the way this one worked is building upon same principles as the homopolar with the Lorenz's force, is we had the I crossed with the B. So when you put this magnet in, you would have, let's see if I put the right way. You can see it starts to kick in. Sometimes, basically, this magnet will make contact with the copper, creating a current loop. So then we have current rotating around. Then you have your B. So then you have a force pulling it and pushing it inside the train. So let's see if, to varying levels of success, it kind of depends on how well that contact is. Yeah. So the last step was basically once this battery rolled down the ramp across the foil, it would make contact here with this push bar, which would then push the battery into position via the magnets and the alligator clips to make electrical contact with this servo motor from an Arduino set, which would then turn on the fan and ultimately push the battery. So that was just a piece of electrical contact to finish it out and get the pencil to the delivery server.